If you do a lot of home inspections or home remodeling that involves checking out wiring, a wiring inspector or circuit analyzer is a neat little tool to have. It can identify a lot of wiring issues without opening up the outlet and looking at the wiring itself. Today I'm going to review the Ideal 61-164 tester because out of these three, it's actually my favorite tester to use. So let's get into it. The unit comes with a small pigtail cord that is replaceable, so you can always put a longer one on if you want, and a carrying case. There are no batteries because it is powered from the outlet that it is measuring. When you first plug the unit in, it takes about 5 seconds for the screen to come up, and if everything is wired properly, it will show you 3 dots indicating proper wiring. It will also show you common wiring errors like an open ground or a hot neutral reverse, but it will not show an open neutral because it needs the neutral to power up the unit. A very important feature this unit has is the ability to identify a false or bootleg ground. This occurs when somebody takes an old 2-wire outlet that does not have a ground wire and wants to replace it with a modern grounded outlet, but they don't actually have a ground wire to run to the outlet. So they will take the ground of the new outlet and tie it to the neutral wire of the old wiring. A standard outlet checker will show this as a properly wired outlet, but it is actually a dangerous way to wire these outlets, and this tester will show that it is a false ground by putting an F on the ground lug on the display. From the wiring screen, you have 4 other screens you can go to. The first one is the current voltage measured on the line. The first measurement you see is your hot to neutral voltage or your regular outlet voltage. Then you can go ground to neutral, which will help you identify issues with your ground or your neutral wire, and we'll cover that in more detail. Peak is a useless voltage. It's your RMS voltage times 1.414. It's just a calculated value. And then Hertz is also probably useless for most people because it's always going to be 60. The next screen is the voltage drop screen, which will tell you how much the voltage will drop at your outlet if you have high loads on it. Like if you have something drawing 15, 20, or 12 amps, it will tell you what percentage that voltage will drop on the wiring. Anything above 5% is supposed to be bad according to the National Electric Code. This was a pretty long wire, so you can see I've got some pretty heavy voltage drops here. And we'll talk about that a little bit more too. The next screen is amperage. ELL stands for estimated load on the line. It kind of tells you how much current is being drawn on that particular breaker. There's some issues with that. Next is available short circuit current 1 and then available short circuit current 2. It basically tells you the amount of current that can be drawn on the wiring if somebody shorted out your plug. I don't know what you care about that for, but it's on here. Finally, you have impedance, which is the actual resistance of your hot, neutral, and ground wire. That's very important when you're looking for wiring errors and other problems, and we'll see how accurate that is and cover that in a little bit more detail next. The impedance function of this tester measures the actual resistance of the wire. Since this is a dedicated wire, I know the resistance. I actually measured it out at 0.38 ohms with a 4-wire ohm meter. So right now I'm showing 0.43 ohms on my hot. That's because that also includes the resistance of the breaker. But if I look at my neutral, I'm measuring 0.39 ohms. So this is pretty damn accurate from the 0.38 that I measured with my 4-wire meter, and 0.39 ohms on the ground wire, which I would expect because this is a controlled environment with the ground and neutral being exactly the same length in my test setup here. So very accurate on measuring impedance. Next, we'll take a look at the voltage accuracy. You can see that I'm showing 115.8 volts in on the Ideal, 115.8 in on the Fluke, so the voltage is looking pretty accurate. The voltage drop screen is basically the meter doing some calculations for you based on the last 2 measurements we just took. So we know the hot and neutral wire resistance is only 0.82 ohms. If you had something plugged into that outlet that was drawing 12 amps, that would be 9.84 volts dropped across the wire, which divided by the 115.7 coming in from the breaker is 8.5% drop that you would have getting to that outlet. If you had something plugged in that was drawing 15 amps, Now that would be 12.34 volts dropped on that wiring in your house, which means that your voltage drops 10.6% at the outlet. The NEC recommends that you don't have any more than a 5% drop on any outlet, and your wiring should be big enough to accommodate that. It's got to be hard to find a lot of homes that all of the outlets would meet a 5% drop with a 12 or a 15 amp load. But it does let you know that if you have something that is going to draw a lot of current, like a computer, that when you plug into these outlets, you could have a significant voltage drop that gets that voltage down to 103, 105 volts. And some computers might have trouble working at 103, 105 volts. So it lets you test outlets in your house to find out areas where equipment may have difficulty running on those outlets. The ground to neutral voltage measurement can be very helpful in identifying issues with balanced and unbalanced grounds. So here's a balanced ground situation where we have two phases running in one piece of Romex. The black and red wire are each a phase and each have their own circuit breaker, but they share a ground wire. So I've taken these two wires and I've ran them to two separate outlets. One outlet will have the one phase on it and the other outlet will have the other phase, but they share a ground wire. So what should happen here is when I have high current flowing from one of these outlets, the current flowing in the other outlet should cancel out that current and you don't have as much current actually flowing on the ground wire. I'm only going through about 50 feet of wire, so that gives me 0.13 ohms of resistance in my neutral wire. Each of these heaters draws 10 to 11 amps, so if I put 10 amps through 0.13 ohms, I'm going to see 1.3 volts drop between my ground and my neutral wire because I'm dropping 1.3 volts on that neutral wire. Now, if I turn this heater off and turn the next heater on that's on the other phase, I'll see the same 1.3 volt drop on that neutral wire because they're sharing that neutral wire. Now, if I turn both heaters on, I'll see 1.3 volts dropped with the first heater on, but turning the second heater on, I'm actually canceling out that current on the neutral wire. So I see 0 volts ground to neutral, even though both of these heaters are on and both of these heaters are drawing 10 amps. Next, let's say somebody did some wiring in the house and plugged those breakers onto the wrong phase, where each of those breakers were plugged onto the same phase instead of opposites. Now, when I turn one heater on, I'll see the 1.3 volt drop hot to or ground to neutral, and turning on the second heater, I'll see the same 1.3 volts ground to neutral. But now if I turn both heaters on at the same time, instead of these currents canceling each other out, I'm going to see 2 volts dropped ground to neutral. Knowing that the wire resistance is only 0.13 ohms and I'm seeing 2.3 volts, I know there's 20 amps flowing through that ground wire. So this meter showed a problem where too much current is flowing on one wire. The estimated line load is pretty accurate, but only when you're using a common ground, not shared grounds, because it's figuring out the amount of load that's on your line, not from the hot wire, but from the neutral wire. So I'm going to use the same setup I used when I was showing you the ground to neutral voltage measurement. The only difference here is that beyond that first outlet that I'm showing you, I am taking that through some additional Romex into another outlet. And then I'm going to have a heater plugged in on one phase that's on that right outlet there, and then another heater plugged in on that outlet on the bottom after going through the other 90 or so feet of Romex. So these guys are on different phases of the circuit. And you're going to look at what the line load drop is as I turn these heaters on. So if I have my tester plugged into the same outlet as one of my heaters and I turn that heater on, I'm getting about 11 amps, which is really close to what is drawn up. It's about 11.5 amps. So it's pretty accurate with the load and the tester in the same outlet. So now let me just move the tester to this outlet so it's closer to the breaker, beyond that 90 feet of Romex that I showed you earlier. And if I look now, I'm showing 10 amps, so still pretty close, pretty accurate. But now here's my other hot that's sharing the neutral. If I turn this heater on and draw 11 amps out of the other hot, because of the shared neutrals, this is showing me only 1 amp of current being drawn now, because this is basing the load on the neutrals, not on the hots. So because of the shared neutral, I'm not getting an accurate representation of how much current is being loaded down on each of these breakers. Right now I'm pulling 10 to 11 amps out of each breaker, and depending on, I'm looking at either hot here, either outlet goes back to those hots. And again, 0 to 1 amp is all that's showing up there. But if I turn off one of these heaters, that will jump right up to the 10 amp load. From any screen on this tester, you can start a GFCI test by hitting the GFCI button. There are 2 types of GFCI tests that this can do. A 6 milliamp test, which is what you would do on your traditional outlets that you see in kitchens and bathrooms. It actually tells you what current is going to be testing at based on the voltage coming in. Since my voltage is a little bit low right now, this is saying it's only going to do a 7 milliamp test, but that's fine for testing most outlets. So to perform the GFCI test, simply hit the GFCI button after you're plugged in and on this screen. And once you test the outlet, the tester will lose power because you've now tripped that GFCI outlet. So once you reset the outlet, it will show you the amount of time it took for that outlet to trip, 142 milliseconds at 6.9 milliamps. So it won't do any of the other testing until after you hit the GFCI again. Now the tester will power back up and do the measurements on this outlet the way that it normally does. One last thing to note about GFCI outlets is when you're looking at impedance, testing outlets, you can't test your ground impedance on a GFCI because that will cause the outlet to trip. So I'm looking at my hot impedance right now my neutral, and as soon as I switch to the ground impedance, I'm going to trip that breaker. This tester will also do 30 milliamp testing, which is called equipment protection devices. You'll find 30 milliamp breakers on things like AFCI circuit breakers that are on the market today. Some of them will have a 6 milliamp GFCI built into them, and some will have a 6 and a 30 milliamp built into them, and some will only have a 30 milliamp test built into them. But this tester will allow you to test the 30 milliamp trip function that are found on many circuit breakers today. That pretty much covers all the features and functions of this guy. I know this video went a little long, but I really wanted to cover everything and show the accuracy and how this worked and how it could be used. I really believe this is one of the best circuit analyzers on the market today. If you're interested in purchasing this, there is a link to it in the description of this video. I will also be doing some reviews of the Amp Probe and X-Tech circuit analyzers, so you can see how those compare to this one. The X-Tech's a little bit less expensive. The Amp Probe has a few other features that this unit doesn't have, and we'll be going through what those are. But from a pure circuit analyzer standpoint, I really believe this is a nice unit. Thanks for watching.